Yesterday we learned how to solve linear systems by graphing. Today we're going to use a new method called substitution, which saves us from having to graph to find the solution. We can do it using algebra without ever having to graph the equation itself. So in order to solve a system of equations by using substitution, our first step is to rewrite one of the equations in terms of either y or x. Sometimes we'll be given an equation that's already solved for y or x, such as in our first example, y equals 3x plus 2 and x plus 2y equals 11. Now, since we're looking for the point where the two lines intersect, the point where their x's and y's are the same, then I can assume that their y's are already the same. So what I can do is I can replace the y in one equation with the y that's solved for in the first equation. I can take my second equation, and instead of having y there, I can put what I know y must be from my first equation. So I substitute in that 3x plus 2 for y in my second equation. Then it's just a matter of going through my algebraic steps to solve for x. So I next use the distributive property, and I add like terms, subtract 4 from both sides, and I get x equals 1 after I divide by 7. So that is the x coordinate where my two lines intersect. I just need to find my y coordinate. So I take that x coordinate and plug it in to the other equation. And I get y equals 5. And I can double check and make sure that works in my other equation by putting in 1 for x and 5 for y. And that does indeed give me a true equation. 1 plus 2 times 5 does equal 11. So my solution is x equals 1, y equals 5, so that I have the point 1, 5. Now sometimes our equation won't be set up as an x equals or y equals. We want to rearrange it to fit that pattern. So we're going to solve one of our equations for one of the variables. Now whenever I have to take this approach, it's helpful to find one of the variables with a coefficient of 1, because that's going to save me as much work as possible. If I look at this first equation, it has x with a coefficient of 1. And so to solve that equation by x, I would simply add 2y to both sides, and it would give me x equals 2y minus 6, or negative 6 plus 2y. So now I can take that and plug it into the second equation for x. So I replace the x in the second equation with what I know x must be from my first equation, 2y minus 6. And then the steps become the same as the previous one I did. I simplify by using my distributive property, and then by adding like terms, and I use my basic algebraic steps to solve. Add 24 to both sides and divide by 14. Gives me y equals 2. So then I want to plug that into one of the other equations to get x. Now the easiest one to plug it into is always going to be this one that I've rearranged here, because that already has x in terms of y. So when I plug 2 in for y, that gives me the least amount of work possible. It tells me that x equals negative 2. And what I can do to make sure I got it right is plug that into both of the original equations and make sure I got it right. Does negative 2 minus 2 times 2 equal negative 6? Well, that's negative 2 minus 4, and it does equal negative 6. Does 4 times negative 2 plus 6 times 2 equal 4? Well, that's negative 8 plus 12, which does equal 4. So since that works in both equations, I have the right solution. Negative 2, 2. want you to give this a try. I'll give you one set of equations. I want you to work through the answer, and see how you do, and then unpause the video and we'll check your answer. So give this set of equations a shot. So our first step is to solve one of the equations for either x or y. And we look for one that has a coefficient of 1. So both of these x's have a coefficient of 1. Those would probably be the easiest. If I use a negative 1, and I have to change the sign or multiply by -1, it's just going to be a little more work than necessary. So to make it as simple as possible, let's alter the first equation by adding y to both sides, which gives me x equals 3 plus y. So I can plug that into my second equation. 3 plus y plus 2y equals -6. Now there's nothing to distribute, so adding like terms gives me 3 plus 3y equals -6. I want to subtract 3 from both sides. Gives me 3y equals -9. Dividing by 3 gives me y equals -3. And I can plug that into this equation here to find that x equals 0. And I can check that solution in both my original equations. To 0 minus -3 equal 3. Putting in 0 for x and -3 for y. And that does work because -3 is +3. To 0 plus 2 times -3 equal -6. Well, 0 is just 0 and 2 times -3 is -6. So that checks out as well. So our solution is the point, and we write it as a point, 0, -3, because that's the point where the two lines would intersect if we graph them. So that's solving systems of equations by substitution. If you have any questions, feel free to ask. If not, you can move on to your homework.